logarithm, no base is given, and what that means is that's a base of 10. That's an implied base of 10. When you don't see it written there, that is an implied base of 10. So if you would like to, you can write 10 in there. It's the same thing. You don't need to, but you can. So the directions on this one, number 37, say expand. So that with those directions, you actually need to know which way to go. This is written as a single logarithm, or I guess condensed as I call it, and you want to expand it. So if you look back at those rules, this looks like the smaller of the sides. You want to expand it out to the bigger. So you want to change this multiplication into addition using that property. And also right here where we've got an option to use that power rule. Now you can actually do this several different ways. So maybe I'll show you two different ways here. What I would do is I'd actually use that power rule first. So I would bring this 2, since this entire quantity is raised to the second power, bring that down in front. So 2 times logarithm of all that stuff. I'm not going to write the 10. It's there. I'm just not going to write it. So quantity a to the 4th power times b. This is actually the most powerful property of logarithms and the most applicable for algebra, is bringing that power down. And if you watch the video over questions 16, 17, and 18, I think that's the rule you needed to solve that algebraically. I showed you a different method to solve it, approximation, but that's what you need to do that algebraically. So now we've done the power rule expansion. Now I want to expand out this multiplication. So this 2 times log base 10. Now this 2 is actually going to go to the entire thing. So when I split these up, I get a to the 4th plus, this multiplication turns into plus, 2 times log, so I'm kind of like distributing this to the stuff inside the parentheses, of b. Alright? Now, we're actually not done yet because of this power. We're bringing these powers down. That's kind of in the implication of expand. So because I already brought down one power, I'm going to bring this power of a down as well. But it only comes down for this quantity. It's not affecting that b term. So over here, that log of 10 of b stays there. This 4 comes down with multiplication. Power comes down with multiplication. So we get 8 log of a plus 2 log of b. So that is question number 37. This is expanded form right there, using those properties of logarithms. Question number 38, and this is the last one. So I think I'll work this one a different method than I did the last one, just so you can see a variety of ways to do this. There's a lot of different properties that are going on here. You can use them in different orders. So it looks like log base 7 of a over b to the 5th, all raised to the 4th power. Alright, log base 7. Alright, so what I did last time is I brought that power down first. I could do it here too as well, but I'm going to show you a different way of thinking about it, just using properties of exponents. So if you like that method, bring that power down in front, and when you expand the division with subtraction, just remember that 4 goes to both logarithms. But I'm actually going to use properties of exponents first. I'm just going to apply this 4 to this quantity, and it's kind of like distributing that power with multiplication. So that quantity becomes a to the 4th on top, b to the 20th on bottom. It goes with multiplication. Power to a power is multiplication. But I can't forget this is inside this logarithm, log base 7. Now I'm going to do this division into subtraction. So split these 2 quantities apart using the property that division is related to subtraction. And the order here is actually necessary, or I should say important. That a, because it's on top, has to go on the front of that subtraction symbol. B has to go behind it because that's on the bottom. So we've done the division into subtraction. The last thing is to take care of these powers again. So the 4 comes down in front of that logarithm, log base 7 of a, minus that 20 comes down in front of that logarithm, log base 7 of b. Now, if you would have done it the other method, you should have ended up with the same thing. If I brought that 4 down, when I split up the a and the b, that 4 was in front of that a already, and that we would get that. I would have a 4 in front of the b term, and then that 5 would drop down and connect with that 4 to give me 20, like the last method. So that's questions 19, well, all of these, 39, 19, 37, and 38.
Words are flowing out like endless rain into a paper cup. They slither wildly as they slip away across the universe.